Hello, so welcome back to another small lecture, okay, part of lecture one. So in that lecture, as you see here on the screen, we're gonna explore another, interesting stuff about binary numbers, which is how to do arithmetic operations on such binary numbers. We know from the elementary school how to do operation on decimal numbers like addition, subtraction, and multiplication. So how can we do that on binary numbers as well? Okay, so we're gonna learn here or revise or review what we learned basically in digital electronics as usual. Okay, but in a very simple form. Let's start by addition. Okay, so let's have an example. So let's start by addition. Okay, and let's have an example here of adding 1 0 1 0 with 1 1 1 1. Okay, then apply what you have learned in elementary school exactly, but here we are dealing with zeros and ones. So 0 plus 1 is 1. 1 plus 1 is 2. Okay, so 2 is 0 1, right? It's 2 digits, it's not 1 digit. So what we're gonna do here, so we're gonna add the 0 here in the final form, final number, then take the 1 as a carry. Exactly what we were doing in decimal numbers. If you have add two decimal numbers, okay, when you have a carry, the carry is 10. Here the carry is 1. Okay. So then we have this carry here. So 1 plus 0 is 1. 1 plus 1, this one here, is 2 again. So 0, and we have another carry of 1. Now we have 3 ones under each other. So 1 plus 1 is 2. And 2 plus 1 is 3. What is 3? 3 is 1, 1. So 1, and we have another carry, which is 1. Okay, and this guy has no, you can just append the zeros here, and 1 plus 0 is 1, 1 plus 0 is 1. So you have finally 1. Okay, so probably when you add two n-bit numbers, the summation may be n plus 1. It can be n or n plus 1. Okay, here it's n plus 1 bit number. Basically, if you add 15 plus 1, so let's do that for example. 15 is just 4 ones, and I will just add 1 here. This for sure will give us 16, which is how much? It's 5 bits. Let's do it. 1 plus 1 is 2, so 0, and we have a carry of 1. 1 plus 1 is 2, again 0, and we have another carry of 1. 1 plus 1 is 2. Of course, 2 plus 0 is 2, still 2, so 0, and we have a carry of 1. 1 plus 1, again 2. 2 plus 0 is 2, so we have 0, and again another carry. Just append the zeros. So 1 plus 0 is 1. 1 plus 0 is just 1. And this is 16. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, which is 16. The good thing here is that you can verify using decimals. So you can just, convert. Let's do that in another color. So you can just convert it to decimal. So let's convert this. This is basically 2 to the power of 0, 2 to the power of 1, 2, and 3. This is 10. And how much is this? This is 15. So 10 plus 15 is basically 25. Okay. So let's verify here. This is 1. This is just 0 to the power of 1 to the power of 2 to the power of 3, which is 8. 2 to the power of 4, which is 16. Good. 16 plus 8 is 24. 24 plus 1 is 25. So this is basically 25, which is, the same result of adding the equivalent decimal numbers, because basically they are the same, they represent the same thing. Okay, so the addition should be the same. When you add 2 apples with 3 apples, you should get 5 apples. Whatever the representation of the 2 and whatever the representation of 3, it's a fact that you should have 5. How you gonna write 5? This is, this is based on the system. You can just write it as 5, in decimal, or 101 in binaries, just the same shape, different shape for the same thing, which is 5 counts. Good. This is addition. How about subtraction? So subtraction is a little bit difficult. Okay, we will still apply the same principles of elementary school, with decimal numbers, but this is not a good way to do all the time, and we're gonna adopt another way to make subtraction, just after this video, or at the end of this video, maybe after or maybe at the end. So let's do subtraction. Let's have another example. So let's subtract those guys from each other. So we have here 1, 0, 1, 1, 0, 1. I'm just, make the number, make a lot of space between the digits just to differentiate, because we deal with each corresponding, digits. And we're going to subtract this guy from that one. So we're 1, 1, 1, then 0, 0, and 1. Okay? Good. So let's do the subtraction here. So 1 minus 1 is 0. And here is the problem now. 0 minus 1, because 0 is less than 1. Okay? So we're gonna borrow something. So just like what we have done in decimal, we borrow 10, then 10, add 10 to the digits that we borrowed for, and sum this and subtract it from the digit below. So, but here when we borrow something, it's 2, not 10. So we're gonna borrow that guy, it will become 0, and this guy become 2. And just you can write it, but with the paper on the hand. We are doing subtraction now with the paper on, so you just write it 2. Okay, and 2 minus 1 is 1. Okay, 2 minus 1 is 1. Now this guy becomes 0. 0 minus 1, again we have the same problem. So borrow again that guy, it becomes 0, and this becomes 2. Then 2 minus 1 is again 1. Now we don't have a problem, because 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 1 is still 0. Can we do verification? Yes. Still we can do verification by just converting, all the 3 numbers to decimal. Okay, so let's do that. So if we convert, let's do another in another color. So if we convert the first one, it would be 45. If we convert the second one, it's 39. And let's do this first, and then compare the results. So 45 minus 39 is basically 6. And if you want me to remind you, let's do it in the same way. So 5 minus 10 minus 9, we can do that. So we borrow 1 from the 4, it becomes 3. And the 5 become 15, because when we borrow 1 from the left hand, the left unit, we borrow it by 10. So this become 15. So 15 minus 9 is actually 6, and then 3 minus 3 is actually 0. So the subtraction should get us 6. Is this 6? Yes. 2 to the power 0, 2 to the power 1, which is 2, 2 to the power of 2, which is 4. 4 plus 2 is actually 6. Right? So we can do subtraction as well on binary numbers using the same concepts that we learned with subtraction with decimal numbers. But we will see later that this is really a problematic to program. And we're gonna do, and for designing a hardware, you should do, the least expensive number of operation, because this operation, take hardware. You need hardware to do it, and you should minimize your hardware. Okay. Now, finally, let's do the multiplication. Let's do the multiplication. So let's continue with red here. Multiplication. And actually, multiplication here is easy. Very easy, because when you multiply something by 1, you will get the same stuff. When you multiply something by 0, you will get 0. Okay, but it's a lengthy operation. Okay, just like decimals. Okay, so let's have an example again. So let's do 1 0 1 1 by 1 0 1. Okay, let's do that. So first you multiply 1 by all those guys, so you will get the same stuff. So 1 1 0 1. Then you shift by 1 bit, okay, and multiply 0 by all those, so you will get just 4 zeros, which is, this is the beauty of doing binary multiplication of binary numbers. Then you shift with another bit, so you start here and multiply this one here by all the 4, so you will get again the same number, 1 1 0 1. Then you just add the 3 numbers together. Okay, you can just imagine here there is a 0, you can just add 0 here and 0 here and 0 here. Then you do the addition. 1 plus 0 plus 0 is just 1. 1 plus 0 plus 0 is just 1. 0 plus 0 plus 1 is just 1. 1 plus 0 plus 1 is 2, so 0, and we have another carry. 1 plus 0 is 1. 1 plus 0 is 1, and we have finally 1. Okay, one comment here is that we have here 4 bits, we have here 3 bits. What we have here in the output, we have 6 bits. Okay, so usually you have the maximum, you may double the number of bits that you want. Okay, so addition may end up with n plus 1 bits. Subtraction, we will have the same, either n or n plus 1, according to the technique that you use for subtraction. And here you may have 2n. Okay, you may double the number of bits. Okay, so basically we see in this small video how to do addition, how to do subtraction, how to do multiplication. We don't have a problem in the addition or multiplication flow. This can be implemented easily in hardware, as we will see in the course. Okay, but we have a problem with subtraction. So we need to find a better way to do the subtraction, something like the addition, for example, something very easy like the addition. So this is what we're gonna do in the next small video, or short video. We're gonna learn another representation for the number, and this representation can help us doing the subtraction in a very easy way. So see you in the next video.